theorem of the mu plus mu minus. So the decay of a single photon is not allowed into a fermion pair unless it is decaying in the presence of matter. Then it can absorb energy from the matter and decay, but otherwise not. So therefore it tells you that if we have a Feynman diagram like this, we cannot immediately jump to the conclusion that the ultimate result of the calculation will be some production cross-section times branching ratio. To put it in a more formal language, somebody was asking me what is virtual and what is real. I will simply say that this photon is actually virtual, and this W depending on the QQ bar energy may be real if QQ bar center of mass energy is more than the W mass, but this can also be virtual, namely when QQ bar center of mass energy is less than the W mass. Now in the Parton model, the QQ bar have a variable energy, so it does not make sense to make a guess whether the W will be virtual or real. Therefore the best thing is to keep the W as a virtual particle propagator, but we will see in which limit we can break this into a production times branching ratio. This is one of the instructive parts of this calculation. So for the calculation, represent W by a so let me write this as QQ bar prime going to W. This W may be real or virtual, I do not commit myself, minus UE. And let me simply write the result. This will be 3 pi and then GF by W square, GF times MW square, the whole thing whole squared. Oh, no, I didn't do this. I kept those things alright. Then S hat and now this is the contribution of the W propagator. Now how do I see that? What is the photon propagator? 1 over Q square. So that appears in the amplitude. What happens in the cross section? That should be further squared. So we should have 1 into the photon has no mass, therefore no mass. So let me simply tell you that in quantum field theory, if we have a massive particle, the propagator can be written as Q square over MW square, where Q is the energy carried by the photon, and the 4 momentum actually carried by the photon. And the whole square of that would be a nice formula. In this case, I have root S because I assume that the center of mass energy of the quarks is given by root S. Then why the hell this gamma W MW square? Now before I tell that, let me simply tell you that if the gamma W MW was not there, do you see the catastrophe that would take place? Because in the denominator we have S hat, which in the Parton model is a variable. The energy of the two quarks is changing depending on which fraction of the proton momentum they are carrying. So, in some configuration, S will be equal to mw square. Sometimes it will be larger, sometimes it will be smaller, and then simply the propagator will blow up if the gamma w mw term is not there. So first of all, let us realize that gamma w mw is actually helping you to get out of the singularity. But what is the physical origin of this gamma w mw? Well, this is the fact that W is an unstable particle, and this is what I will show by a very simple argument. Actual rigorous argument of course exists, but let us say that since the W is virtual, we have to play with its mass. Now, we have already seen an example, the invariant mass distribution does not peak at the mass itself, but it has a width, which is the width of the decaying particle. And here something very similar is happening. Let us see. So let us do some elementary quantum mechanics to understand this. So what is the wave function of a free particle in quantum mechanics? I am not worrying about the x dependence, but we all know that this is minus IEP over H cross. Alright? Now what does that mean? If I calculate the probability density, it will be time independent. It can be space dependent, will be determined by psi of x, but time dependence is very much absent. So this represents a stable particle. How do I have an unstable particle? Well, you know from radioactivity that time dependence should be like e to the power minus gamma t, where gamma is the width. So therefore, we say that we replace m by m minus I gamma over 2, where gamma is the width of the particle. Now what happens? Suppose we go to the rest frame, then what happens? Then psi xt will be again psi x, and then energy is the rest mass energy. So it will be power minus m minus I gamma over 2 times t over h cross. And what happens to the probability density? Now clearly the time dependence will go like the m term will again absent as soon as we take the mod square. But because of these two i's, this is a real term with negative sign, and therefore when I square it, I will get e to the power minus gamma t, and this is the correct exponent shear Therefore, if we have this prescription in mind, as I told you, rigorous thing exists. Alright. So I will now write the propagator as is hat minus mw square whole square, but not quite. I should also write this as mw minus I gamma w by 2. So I am just expressing the mass by a combination of mass and width. So this, let me call this P. So this comes in the rest frame. I am sorry, this comes in the amplitude. So therefore in the cross section, what you will have, mod square of the amplitude is the cross section. So what you have here is P star, and this is equal to exactly the term I have written